In this video, we'll tackle word problems that involve quadratic equations and explore the different ways to solve them. So for this problem, looking at what the question is asking, says how long will it take the ball to hit the ground? And we have this equation right here. We can use a program like Desmos to take a look at what this graph looks like, or even understanding the parent function, where we have a negative out in front of our t squared variable, means that we'll have a downward facing parabola. If this number was a positive, we know it would be an upward facing parabola, and that can help us solve this problem. So given in this situation, we do have a downward facing parabola. If we were to graph it, it would look something like this. So given that we have a soccer ball, it starts right here at the point 0, 0. It's going to be kicked up in the air, and then it's going to land back down. The question is asking how long will it take for the ball to hit the ground? So if we're looking for how long, that means in terms of time. And we know that t is going to be our x-axis variable. So we're looking for how much time it's going to take until it reaches the ground. If we were to think about this in terms of a point, we know that t would be our first variable, or where we put x, and that our y is going to be 0, because we want to know exactly the height of it for when it hits the ground. With that information, it'll help us set up our equation. We know that h of t, or what we're going to plug in for y, is going to be equal to 0. So then, therefore, we're going to be solving for what t will be equal to. And we know that we're going to have two answers that come out of it because there's 2 points on this graph where t is equal to 0. So solving this, we can actually factor out a variable of t as well as a number of 16. And so what we're going to be left with, if we do this, is going to be a negative t plus 3. When we have this set equal to 0, that means that either one of these items must be equal to 0. For instance, if we have 0 times a number 3, it's always 0. If we have 0 times a number x, that's always 0, meaning that if this was 0, the 16t, the whole item over here wouldn't matter what it equals, because this is always going to be 0 as well. Meaning that if 16t was equal to 0, it really wouldn't matter what this negative t plus 3 is, because no matter what, 0 times something is always going to be equal to 0. So that helps us set up this equation by saying 0 is equal to 16t, and also 0 is going to be equal to negative t plus 3. If we were to solve this, we can divide by 16 on both sides for this one, and t is going to be equal to 0, which is going to correspond to this point here, when the soccer ball was first kicked. If we subtract 3 on both sides, we'll have negative t is equal to negative 3. We can multiply both sides by negative 1, and what we're going to end up getting is t is equal to 3, meaning that at this point, when time is equal to 3 seconds, the ball will hit the ground. So our answer is going to be equal to 3 seconds. For this question, it's asking us to figure out the number when we have something that's the difference between a number and the positive square root of that number is 30. There's a couple things that can help us with setting this up. The word difference is going to mean subtraction. And then we also have this word is, which is another synonym for equal. So we can set up this equation as a difference of a number, which we'll just call x, minus the square root of x is equal to 30. The quickest way to solve something like this is actually to do substitution and say that x, or the square root of x, is equal to y. And if that's the case, x would be equal to y squared. The reason why is that if we take the square on both sides of these numbers, the square root and the squared will cancel out, so we'll be left with x is equal to y squared. So we can plug this in as y here, and plug this x in as y squared here. So we'll have y squared minus y is equal to 30. Subtract 30 on both sides, so that we'll have y squared minus y minus 30 is equal to 0. We can use the diamond method by putting the last number, the one without a variable or y associated, to the top, and a negative 1, which corresponds to that y, for the middle variable. We want to figure out a set of two numbers that would multiply to 30, but add to negative 1. Those two numbers would be minus 6 and 5. With these two numbers, we can put it into parentheses form, or we'll have y on the left side within each parentheses. And we'll have the two numbers that we found, minus 6 here and plus 5 here, and that's equal to 0. We can solve for y in each case using the same format that we did for the last problem. We'll move 5 or 6 to the other side, so we'll get y is equal to 6 and y is equal to negative 5. Now remember, it says that we must have a positive square root, and y being equal to the square root of x means that we cannot have y is equal to negative 5. So y would be equal to 6, which means plugging it back in, x would be equal to y squared, which is 6 squared, so x would be equal to 36. In this question, we're going to be solving for the length and width of a garden. It tells us that the area is equal to 360 meters squared, which would be equal to the length times the width. Now the problem tells us that the length is 5 meters more than twice the width. This word is means it's equal, and when we see more than twice means 2 times. So that would tell us that the length is equal to 2 times the width plus 5. So we can plug the length variable in here to get that 360 is equal to 2w plus 5 times w. So with that information, we can multiply this all out so that we'll get 2w squared plus 5w is equal to 360. We would move the 360 to the other side, so we'll get that 0 is equal to 2w squared plus 5w minus 360. For a problem like this, it would be best to use the quadratic formula to solve. And the quadratic formula is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, where a will be equal to 2, b will be equal to 5, and c will be equal to negative 360. If we plug these values in, we're going to get negative 5 plus or minus the square root of 5 squared, which will be 25, minus 4 times 2 times negative 360, all over 2 times 2. If we simplify this, we're going to get negative 5 plus or minus the square root of 2905 over 4. Now this will give us 2 different answers, negative 5 plus the square root of 2905 over 4, or the option of negative 5 minus the square root of 2905 over 4. But this is going to be a negative value, and we can't have a length or a width that's a negative number. So that negative value can't happen. And so the only answer would be this. If we use a calculator to solve this, we're going to get roughly negative 5 plus 53.9 all over 4, which would simplify to roughly 12.2. Now that is going to be the value for our width. Our value of our length is going to be by plugging this value in here for 12.2. So our length for this is going to be equal to 29.4, and those will be our 2 numbers. For this problem, it says the product, which is going to be the multiplication of 2 different numbers, and it says 2 consecutive even integers is 168. Again, this word is going to mean equal. So we'll have 168 is equal to some number, and then the next, which is going to be consecutive, even integer. So that would be x plus 2. If we were to multiply this all out, we'd have x squared plus 2x is equal to 168. We're going to move this 168 over to the other side because we want to get 0 on one side and all of our variables and numbers on the other side. Once we have that, we can be able to solve. Now there's a couple different ways that we can solve this. Probably the easiest to do is to first check to see if we can solve by the diamond method. So what 2 numbers would multiply to get 168 but add to 2? We could do the quadratic formula, but that's always a little bit lengthy. And for this one, we're actually going to get negative 12 and 14 as our 2 numbers, meaning that if we put this in parentheses forms, we're going to get our variable x on the left and minus 12 and plus 14. If we solve for these 2 numbers, again, we'll have x minus 12 equals 0 and x plus 14 is equal to 0. And that's going to give us that x would be either equal to 12 or x would be equal to negative 14. Now the answer is asking for integers, and integers can be either plus or minus. If that's the case, when x is equal to 12, the next product of the second consecutive even integer would be 14. If x is a negative 14, the next consecutive even integer moving upward would be negative 12. and those would be our two answers. For this problem, we're looking for the length of a side of a square, and it says that the square has an area equal to the sum of 4 times its side length and 21. So sum being the addition of 4 times its length and 21, meaning 4 times the side plus 21. And that's equal to the area. And remember, the area of a square is equal to s squared, where s stands for the side. So for this problem, we're going to subtract 4s and 21 from this side and move it to the other side. So we'll get s squared minus 4s minus 21 is equal to 0. So with this, we can try using the diamond method first, and hopefully that it's easier to solve than doing the quadratic. And we'll notice that our answers are going to be -7 and +3, meaning that we can set this up and factor it with parentheses, where s can be s minus 7 times s plus 3, to where we'll have s minus 7 equals 0, so s will be equal to 7. S plus 3 is equal to 0, so s will be equal to -3. We can't have the negative side length, so the only available option be that s is equal to 7.